All right, what's up? Welcome back to Math and Beats. Today we are going to introduce the concept of a function. So let's get right to it. To do this, we're going to first refresh our memory about what a relation is. A relation, if you recall from a previous video, is any set of ordered pairs. It's a collection of ordered pairs. We often write a set using these braces, and for a relation, inside is a bunch of ordered pairs. So in each ordered pair, we have a first coordinate and a second coordinate. In this case, first coordinate is x and the second coordinate is y. So that is a set of ordered pairs, just to refresh your memory. We refresh this because a function is some type of special type of relation that ends up. So let's get an idea about what a function is by considering the following example. Let's consider the relation in which the first coordinate is the age, let's say in the number of years, of persons living in San Jose, California, and the second coordinate is the number of cars the according person owns. So we can make up some stuff here. Perhaps there's some person, they're 22 years old and they own one car. There's another person, let's say they're 25 years old and they own one car as well. And finally, there's a third person, let's say they're 32 years old and they own two cars. Finally, let's have another 25 years old, and they own three cars. So we can make a little diagram as we did in the past. Draw a little diagram here. This one is going to represent the collection of first coordinates. This is the number of years old of some persons. We have three different first coordinates here. They're the number 22, 25, and 32. In our second little oval looking thing, this would represent the collection of the second coordinates, which is the number of cars a person owns. And we can make a little diagram to say how many cars each of these persons owns. So the 22-year-old, they have one car. The 32-year-old has two cars. And then the 25, well, there's actually two different people that have the same first coordinate, two different 25 years old. And as expected, there's many different people out there with the same age, at least a number of years. And so in this case, 25 years old, they actually have one car, and there's some other 25-year-old that has three cars. So this is an example of a relation, and we can write it using our notation with the brace. First order pair, we'll use 22 is the number of years old. That person has one car. Then there's a 25-year-old who has one car. There's another 25-year-old who has three cars. And then there's a 32-year-old who has two cars. So again, by definition, it's an example of a relation. But one thing we want to point out here is that we see two different ordered pairs with the same first coordinate of 25. And there are two different second coordinates. Ends up, this is not good for our definition of a function. It violates the definition of a function, even though the entire set is a collection of ordered pairs, which is a relation. It's actually not a function. So what is the definition of a function? A function is a relation, collection of ordered pairs, in which every first coordinate has, and here's the important part, exactly 1 second coordinate. As you can see in the example above, that's not true. The first coordinate of 25 has 2 different second coordinates, and hence it is not a function. So we want to be able to distinguish between relations in general and special types of relations, which we call functions. Functions are a huge topic in mathematics. To help us get a little bit of a better grasp on this idea, we're going to consider another example. And so in this example, we have 2 different scenarios, and we want to determine in each of these scenarios whether each relation is a function or not. In the first situation, part A, we have a relation in which the first coordinates are the social security numbers of each person living in San Francisco, California, and the second coordinates are the corresponding person's driver's license number. Let's just assume there's no funny business going on here, no fraud or shady stuff, and it's the situation in which you would expect, and that is you have for every social security number, which is unique to each individual, assuming a person can drive, then each of those persons has also a unique driver's license. So you kind of think of a couple different people here. Maybe we say person 1 has social security number 1, social security number 1, person 2 has social security number 2, and person 3 has social security number 3. They each have a unique social security number. If they can drive, which we'll assume they do for now, then person 1 is going to have driver's license number 1, whatever that is. They don't have 2 different driver's license numbers. They only have 1. Person 2, they have driver's license number 2, whatever that is for that person. And person 3 has driver's license number 3. And we could go on with the rest of people that live in San Francisco, California, and have a driver's license number. Each person has a social security number that is unique to them, and assuming they can drive, they have a unique driver's license number as well. In this situation, this is indeed a function. So we say this is a function, this relation is a function, since each person has a unique social security number and a unique driver's license number. It's not going to be possible for one person to have 2 different driver's license number, and because of this, it doesn't violate the definition of what a function is. Hence, this is a function. Now, in the second situation here, we're going to consider a relation in which the first coordinates are the height in inches of each student at some random high school, and the second coordinates are the corresponding student's first name. So we can make up some stuff here, some random high school. Let's just make up a few things. Maybe first person, they are 65 inches tall. 65 inches, first coordinate. Maybe another person is 66 inches. And then there's some other person as well as 65 inches. It's quite possible that many different people are going to have the same height, at least in inches, not considering little fractions of an inch or anything. So we can imagine that in this situation, a person who's 65 inches tall, which is 5 feet 5 inches, maybe that person's name is Joe. A 66-inch person, perhaps, is Mary. And another 65-inch person is, I don't know, Sally. So as we can see, the first coordinate of 65 inches has two different second coordinates. If we were to write this out as a set of ordered pairs, we would have something like 65, comma Joe, 66, comma Mary, and 65, comma Sally. As we can see again, the first coordinate of 65 has two different second coordinates, which violates the definition of a function. So this relation is not a function, since the first coordinate of 65 has two different second coordinates. And that, of course, violates the definition of a function. It still is a relation, but it's not a function because you're going to have people with the same height, but of different names. It's bound to happen. Can you imagine a universe for which this doesn't happen? Maybe, but not in this random school, as we're going to assume. So, to refresh, we have a relation is a collection of ordered pairs, a set of ordered pairs. In example 1, we saw a scenario in which the first coordinates were the age of some persons living in San Jose, California, and the second coordinate, the number of cars that the according person owned. We made up some things which could very well happen, and we saw that some person that was 25 years old had one car, and another person that was 25 years old had 3 cars. So the first coordinate of 25 had two different second coordinates. That violated the definition of what a function is. A function, of course, is a relation in which every first coordinate has one and only one, exactly one second coordinate. In our last example, we saw two scenarios in which the first one had a relation where the first coordinates are the social security numbers of each person living in San Francisco, California. The second coordinates, the corresponding person's driver's license number. Each person has a unique social security number and a unique driver's license number, so every every first coordinate had exactly one second coordinate, hence that was a function. And in the last example, the relation in which the heights of each student at some random school, heights in inches, had a second coordinates that are corresponding students' first names. We made up some stuff, and as we can see, it's very likely that there are going to be two different people with the same height but have different names. In particular, we made up some heights of 65 inches, and there were two different people named Joe and Sally that were of the same height. This produced a scenario in which one first coordinate of 65 had two different second coordinates, which violates the definition of a function. So there are many different ways to represent functions. It ends up, the different representations can be viewed in videos at a later time, but hopefully this gives you a nice introductory concept of what a function is. All right, so that's it for now, and Math and Beats, stay tuned for a little bit of beats. All right, later.